Alrighty guys, if you've just tuned in, this is Tenfold Live and we are proudly brought to you by Liberty. We are here covering some analytical geometry questions and some of them are really great guys, they are really challenging. They're going to throw us majorly in the deep end with our analytical geometry understanding. So really good stuff coming to you from this live show. Just a reminder guys, if you have friends who want to watch the show and they don't have a TV, our app has a live streaming function where you can watch this show on your app. So make sure you download Tenfold Education app. You can watch our show, interact with us, send us questions, etc. It's a really, really great app. For now, we're going to jump into our second question. It's sent to us by Masanya. Let's see what he needs help with.
Hi Tenfold, my name is Nandita. May you please help me with the following questions? Thank you.
Oh lordy, that's my bad guys. This question is from Nandipa. I'm so sorry. I'm really excited about this question though. It's a really great question. Let's just jump right into it because there's quite a lot that I will need to get through and help you understand. It says the line 4y minus 3x equal to 24 cuts the x-axis at point P and the y-axis at point Q. Basically all we have to do for this question is calculate the coordinates of both P and Q. Okay, so what you guys need to make sure you note here, cuts the x-axis at P and the y-axis at Q. That should immediately tell you something that at P, the y value is 0 and there's some x value. And at Q, it's the other way around. Because it cuts the y-axis at Q, x is 0 and it has some unknown y value. Okay, now we've been given this equation. It's a straight line equation, guys, but it is not in normal substantive form. So I want to get this into our normal form. So 4y minus 3x equals 24. Well, let's say 4y, because we're trying to isolate y, is equal to 24 plus 3x. Divide the whole thing by 4 and we get y is equal to 24 plus 3x all over 4. If we try and get it into the normal form, we want to get y is equal to mx plus c. So m would be 3 over 4 multiplied by x, and 24 divided by 4 is 6. Okay, so that is the standard form of our graph there. But now we need to find the coordinates of P and Q. So easy peasy, guys. For P, we make y equal to 0. So we say 0 is equal to 3/4 x plus 6. Let me double check I have this straight. X-axis y equal to 0. Perfect. So that means that 3/4 x is equal to negative 6, which means that x is equal to negative 6 tip and times multiplied by 3 over 4, which just gives us, this is 2, that's 1, so it is negative 8, which means that the coordinates of P are negative 8 and 0. Okay, so that's important. Next, for Q, we make x equal to 0. So we say y is equal to 3/4 of 0 plus 6. So that means that y is just simply 6, which means that the coordinates of Q are 0 and 6. Easy peasy, guys. But this next part is a little bit challenging. Okay, I've drawn a Cartesian plane so I can help you visualize this stuff. So remember, we had P, let me double check this. P was at negative 8 and 0, and Q was at 0 and 6. Okay, so 0 and 6 is about there, which is Q. And P was at negative 8 and, whoa, yeah, negative 8 and 0. Okay, so now they're saying, find the coordinates of S on PQ so that 3PS is equal to 2PQ. Okay, so S lies on the line of PQ. So I'm going to draw the line PQ quickly. And I know that S lies somewhere along this line. Now remember, guys, that line is defined by y equals 3/4 x plus 6. Remember that, that is very important. Secondly, it gives us this stuff here. So I'm going to try and manipulate it so I get a nice ratio. If I say 3PS is equal to 2PQ, that means that PS over PQ is equal to 2 divided by 3. So the ratio of the side PS to PQ is equal to 2 to 3. Okay, for every 2 units in PQ or PS, there are 3 units in PQ. Okay, so that's what that means. So here, somewhere along this line, there is a point S, so that, let me put S on here anyway, so that PS divided by PQ gives us the ratio of 2 to 3 from here. Okay, so guys, this is now testing your application of similarity in geometry. Remember, if you have similar triangles, their sides are in proportion, which means that the ratio of this side to that side is the same as this side to that side in similar triangles. Okay, so let's try and find some similar triangles in this diagram that can help us work with this given ratio that we have. Okay, if I look here at the diagram, if I look at this point S that I've plotted here, if I just draw that line in there, okay, that's going to give us, we know that the axes intersect at 90 degrees, and that is a straight vertical line, so that's 90 degrees. This angle will be equal to that angle because these lines are parallel. Okay, so now we have our similar triangles, guys. We have this little one here is similar to the big one here. Okay, I'm going to take that out because it's complicating our diagram. Okay, so we have these ratios here that I've done. PS over PQ is 2/3. So any of the other ratios with the similar triangle sides are going to equal that 2/3, guys. That's how ratio works. Everything is in proportion, same proportion. So let's try and find some sides to work with. This height here is just that y value of Q. So that is 6 units. This height here, therefore, would be the y value of S. Okay, so if I take short side over long side, which I did here, this was the short side and that's the long side, I get 2/3. So the short side here would be given as SY over the long side, which is that 6 units, is equal to the same ratio because they're all in proportion. Oh, goodness gracious. Okay, so if we solve for that y value of S, we get 2 times 6 all over 3, which gives us 12/3, which equals 4. So that means that that y value at S there is 4. Now we need to find the x value. So that's why I made a point over here that it sits on this line. Okay, so we can now go and substitute that x value into that line. Okay, well, we've got the y value, so we know we said that y is equal to 3/4 x plus 6. Double check that. Oh, yes. Okay, so we know that the y value is 4. It's equal to 3/4, the x we're trying to solve, plus 6. So if we try to isolate x, we get -2 is equal to 3/4 of x, which means that x is equal to -2 times tip and time the fraction because we're dividing by it. And that gives us -8/3. So finally we can say x value is -8/3, y value was 4. Okay, and that is going to give us this point here so that it divides that last side into that ratio. Okay, guys, whenever you get an equation that says 3PS is equal to 2PY, try and manipulate so you have the side over the side is equal to a ratio. That means that all the triangle stuff are in the same proportion. Okay, hopefully this helped you apply your Euclidean to your analytical. It's a really great question. Thank you for sending it in, guys. For now, we're going to jump into a career video. It's a really great video. It shows you how this analytical geometry can actually help you forward your careers after school. So please stay tuned. It's a great video.
I'm Barry Baumgart. I'm a registered physiotherapist. Been practicing for 15 years now, specializing in orthopedics and sports injuries. So physiotherapists are trained to assess and treat a various range of pain syndromes or injuries. We do so with detailed physical examination, and then a variety of treatment techniques. So the thing I love most about my job is meeting different people. So different people with different backgrounds, different problems to solve, and a variety of new challenges day to day. So I basically problem solve their issue to try and get them back on track and try and get them well again. So maths and science is important in my work on a daily basis because we're constantly using the measurement of angles, the measurement of loads in various joints at certain junctions, and tension held in muscles as part of our evaluation. My understanding of analytical geometry is measuring forces in the form of vectors, and that is applied directly in how we evaluate movement at certain joints and the load that's taking place there. We use those readings to help with our corrective and rehabilitative exercises that we prescribe to correct the biomechanics around a joint. I think that the most fascinating part about my job is the study and functional understanding of anatomy and physiology. So it's seeing how the body's been made, how it's been created, understanding what can go wrong with it, but also understanding how it can be healed. And so it is amazing to just consider everything that makes us human beings. So how I see my physiotherapy career blending very well with other things I'm passionate about is that I've worked a lot with break dancers, myself being one, in trying to help them and other dancers to achieve optimum levels of performance. And I've just seen how the physiotherapy knowledge of science has blended perfectly with art to have given dancers the best approach to injury prevention training methods. So what influenced me to choose physiotherapy as a career was probably realizing that I wanted to work with people. So I wanted to interact and work to help people. My dad is a medical doctor, so there was a strong medical influence, but I knew I did not want to handle blood and guts and gore, but I did want to help people. So being active, I thought I'd like to work with people who are keen to get back into activity, back to normal life. The type of person who's suited to be a physio, I think, is somebody who does love people, love being around people, interacting with people, and who has a certain patience to hear other people's burdens and aim to help them be free of it. Yeah, people's person would be the best fit for physio.
Wow, guys, what are the odds that I would be placed on this show because my mom's actually a physiotherapist? Hi, Mom! So that career video actually rang true a lot for me because growing up watching my mom do her physiotherapy, using that weird little thing that dude was measuring the guy's arm with, it's called a goniometer. It basically measures your range of motion. But that shows how analytical geometry can be applied in even a medical field. It's really cool, guys. So I really enjoyed that career video. If you like what you see, download the app. It's got so many more videos like it, and it's such great content for you guys. We've assembled it with you in mind, trying so hard to help you with your matric. Even grade 10 and 11 is on there for maths and science. So go and check out that app. For now, we're going into our wildcard question. And guys, it is that easy. Send in a question video and you could win a TV. You have a 1 in 5 chance every show to win a TV. And that's exactly what Nelly Siwe has done today with her wildcard question. Thank you so much for your question. You've won a 19-inch TV, so congratulations. We'll be in touch with you about that. Let's see what question won you that TV.
Hey, I'm Nelsie Wentlekwa. I would like you to help me with this question. It's a question based on functions. Question 4.
Okay, so this is kind of in tune with what we were doing last week with our differential calculus. It's a really great question. It's got a lot of parts to it, so I'm going to try and get through all of them. I'm really sorry if I don't. I'm on a time crunch, but I'm excited about this question. Let's get to it. It says, given that f of x is defined by the equation of negative ax squared plus bx plus 6. First question, it says, okay, furthermore, the gradient of the tangent to the graph of f at the point -1 and 7/2 is 3. Show that a equals 1/2 and b equals 2. Okay, that is a lot of information to take in. So, firstly, the thing that should jump out at you, the moment you see gradient of the tangent, your mind should immediately go to the first derivative. Okay, because when we find the first derivative of a graph, it means it's going to help us find the gradient of the tangent to the graph at that point. Okay, so gradient of tangent, first derivative. Second thing, it says that that gradient is equal to 3 at the point where x is equal to -1. So how we interpret that is f prime of -1 is equal to 3. Okay. So that's the first thing that we can interpret. We can also see that this point, this whole point here, lies on the graph, which means that f of -1 is equal to 7/2. Okay, so when we're trying to find two variables, guys, what you need to look for, if you have two unknowns, you need minimum 2 simultaneous equations to try and solve for those variables. Okay, so that's basically what we've got here. We've got our first derivative, and we've got a point that lies on the original graph. Two different equations that involve a and b, 2 simultaneous equations to find them. Okay, so let's write out these equations. Firstly, I'm going to find f prime of x. Okay, so it was given to us that this is the equation of f of x. So f prime of x is equal to -2a. Remember, a is a constant, so it needs to stay there, multiplied by x plus b. The x disappears because you subtract 1 from its exponent. Okay, so remember we said f prime of -1 is equal to -2 multiplied by a multiplied by -1 plus b, but it was given to us that it's equal to 3. So that means that -2 multiplied by -1 is just 2. 2a plus b is equal to 3. And I'm going to try and isolate b to make sure that I can solve simultaneously. So I'm going to say b is equal to 3 minus 2a. And that is equation 1. We're looking for two equations. Okay, so the next thing, we've dealt with this. Next thing is that f of -1 is equal to 7/2. So that means that f of -1 is given to us as negative, let me double check, negative ax squared plus bx plus 6. Okay, so we get negative a multiplied by -1 squared plus b multiplied by -1 plus 6, and that was given to us as 7/2. Okay, so that means that negative a minus b plus 6 is equal to 7/2. If we try and isolate some variables, we're going to get that negative b is equal to, this is 6, not c, look at me talking rubbish, 7/2 minus 6 plus a. Okay, so we're going to get that negative b is equal to 7/2 minus 6, where the denominator of 2 is 12/2. So 7 minus 12 is negative 5/2 plus a. Okay, now I'm trying to isolate b on its own, so I divide through it by a negative, and I get 5/2 minus a. Okay, so that is our second equation that we solve for simultaneously. Now, if we look at both of our equations, they are both in terms of b. So we can just equate the second halves of these equations and solve for a. So we get from our first equation, 3 minus 2a is equal to 5/2 minus a from our second equation. Okay, so I'm going to bring this 2a over this side, which gives us a. Subtract 5/2 from that side. 3 with a denominator of 2 is 6/2, minus that 5/2 is equal to a, which means that a is equal to 1/2, which is what we're required to prove in the first place. It shows that A is equal to a half. Okay, now to solve for B, we just pick one of our equations. I'm going to choose the first one, so I'm going to say this equation and substitute my value for A in, and I will get B. So from that equation, from equation 2, we had B is equal to 3 minus 2A, which is equal to 3 minus 2 multiplied by a half, which is 3 minus 1, which is 2. So B is equal to 2. And those are the two things that we had to prove. Let's jump into the next part of this question. It says, calculate the x-intercepts of f. Okay, so remember, f of x was given to us as negative ax squared plus bx plus 6. We've now found a and b, so we can say it's equal to negative a half x squared plus 2x plus 6. Okay, so x-intercepts means that y is equal to 0. Okay, so we make this whole thing equal to 0 and we solve for x. I'm going to divide through by negative a half, so that just gives us x squared. 2 divided by negative a half is basically the same as saying 2 multiplied by negative 2, so we get minus 4x, and 6 divided by negative a half is negative 12. And now this is an easy case of factorization. We get x plus 2 and x minus 6 is equal to 0, which means that the x-intercepts are at negative 2, 0 and 6, 0. Easy peasy. Next question, it says calculate the coordinates of the turning point of f. Okay, remember that A is negative, which means that the graph is going to look like this. The turning point up there is going to have a very horizontal tangent. Remember, guys, when you have a tangent to a graph and it's got literally a horizontal tangent, it means that the gradient of that tangent is 0 because there's no change in y. It just goes straight. The y value doesn't change. Okay, so when you're trying to find the equation or the gradient of that tangent, remember, use the first derivative. Okay, so I'm going to say f prime of x is equal to 0. Remember, f of x was given to us as negative a half x squared plus 2x plus 6. So that means that f prime of x is equal to 2 multiplied by negative a half is just negative 1 plus 2. Okay, but remember, f prime of x is equal to 0 at the turning point. So if we say negative x plus 2 is equal to 0, that gives us negative x is equal to negative 2, which means that x is equal to 2. So the turning point has an x coordinate of 2, and now we just simply substitute that 2 value into our original function value. So we get that y is equal to negative a half multiplied by 2 squared plus 2 multiplied by 2 plus 6. And that's going to give us negative a half multiplied by 4 is 2, or negative 2, plus 4 plus 6, which gives us 10 minus 2, which gives us 8. So those are the coordinates of the turning point. Simple. Now guys, I'm severely running out of time and I really wanted to get to this, but the last question was to sketch the graph of f. Okay, so what you need to remember, it says include all intercepts with the axes. We found the two x-intercepts. You now need to find the y-intercept. You also need to plot the turning point. Okay, so you have the two x-intercepts, turning point, y-intercept, and you join them all and you make that nice little concave down parabola. Okay, great question, Nelly Siwe. Really fantastic question for your functions revision and your calculus. For now, we're going to jump into another ad break because my brain needs a little bit of a rest, and I'm sure yours does too, but stay tuned. We will be back right after this.